Hi class 9 students, welcome back again. So today we are going to start your first chemistry chapter, that is structure of the atom. This is the lecture number 1. So here we will first study the introduction and we'll do an activity. We have learned that atoms and molecules are the fundamental building blocks of matter. So atoms and molecules, these are the fundamental building blocks of matter. Now can you see, this is gold, which is a matter, this is gold foil, and these are the atoms of gold. Now you might be thinking that what makes the atom of one element different from the atom of another element, right? Also you might think that are atoms really indivisible? So we shall find out the answers to these questions in this chapter. Now let us do an activity. Comb dry hair. Now does the comb then attract small pieces of paper? Of course the comb will attract the small pieces of paper. Now take a glass rod and a silk cloth. Now rub a glass rod with a silk cloth and bring the rod near an inflated balloon. Let us see what happens. The glass rod attracts the balloon. The glass rod will attract the balloon. Clear? Now what do you observe? So from these activities, we can conclude that on rubbing two objects together, they become electrically charged. So here the charged objects are the glass rod and the comb, because they are being rubbing with two objects together. Clear? Now we know that an electrically charged object can attract an uncharged object. So in both the experiments, the uncharged objects are the balloon and the pieces of paper. So we got to know that electrically charged object can attract uncharged object. Now where does this charge come from? So the charges are coming from within the atoms, which is present in the comb and the glass rod. So atoms are present in the glass rod and in the comb. So from there the charges are coming. So these simple experiments tell us that some charged particles are present in the atoms of matter. So the atom is divisible. I hope everyone is clear. We will see the discovery of electrons and Thompson's atomic model. Many scientists contributed in revealing the presence of charged particles in an atom. So now we will see the discovery of subatomic particles. It was known by 1900 that the atom was not a simple indivisible particles but contained at least one subatomic particles. So around 1900 it came to know that the atom was not a simple and indivisible particles but it contained at least one subatomic particles. Now see, this is the scientist J.J. Thompson, a British physicist who was born in Chatham Hill, a suburb of Manchester, on 18 December 1856. He was awarded the Nobel Prize in Physics for his work on the discovery of electrons. So J.J. Thompson, he discovered electrons and won the Nobel Prize in Physics. He directed the Cavendish Laboratory at Cambridge for 35 years, and 7 of his research assistants subsequently won Nobel Prize. Now let us see the Thompson's atomic model. Thomson passed electricity at high voltage through a gas at very low pressure taken in a discharge tube. So guys, see, this is the discharge tube where Thomson passed electricity at a very high voltage through a gas, and the gas is at very low pressure taken in a discharge tube. Now there are streams of minute particles were given out by the cathode. So streams of minute particles means very small particles it were given out by the cathode. Now cathode means the negative electrode. Then these streams of particles are called cathode rays. So these streams of particles, these are called the cathode rays. These are called cathode rays because they were given out of cathode. Then this cathode rays consist of small negatively charged particles called electrons. Now this cathode rays, it consists of small negatively charged particles called electrons. Since all the gases form cathode rays, it was concluded that all the atoms contain negatively charged particles called electrons. Now all the gases, it form the cathode rays. So we can say that all the atoms contain negatively charged particles called electrons. Am I clear to you, students? Next we will see the canal rays, protons and characteristics. So Thomson proposed the model of an atom to be similar to that of a Christmas pudding. So Thomson, he proposed that the model of an atom it is similar to that of a Christmas pudding. The electrons in a sphere of positive charge were like a currents, that means the dry fruits in a spherical Christmas pudding. So the electrons in a sphere of positive charge were like the dry fruits, like in a Christmas pudding. These are the electrons of negatively charged and which are embedded on positively charged matter, while the electrons are studied in a positively charged sphere like the seeds in the watermelon. Can you see how the seeds are studied in the watermelon? So similarly, the electrons are studied in the positively charged sphere. Then Thomson proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. So it is similar to that of a watermelon. So this is the positive charge and the seeds are the negative charge, that means the electrons. So the electrons are embedded on the positive charge. Then here the negative and positive charges are equal in magnitude. So the atom as a whole is electrically neutral. So here the negative and the positive charges are equal in number. So the atom as a whole is electrically neutral. Neutral means yes, there is no charge. Now see the characteristics of an electron. Mass of an electron. The mass of an electron is about this much, 1 by 1840 of the mass of the hydrogen atom. Then the mass of an electron is so small that it is considered to be negligible. This one is so small, that means the mass of an electron is so small that it is considered to be negligible. Now let us see the charge of an electron. The absolute charge on an electron is 1.6 into 10 to the power minus 19 coulomb of negative charge. So the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. Just try to remember this value. Alright. Now the relative charge of an electron is minus 1 and the relative charge of an electron is minus 1. Alright.